Let's wait a moment for all participants, please. Let's wait a moment, please. Good morning. My personal greeting to all our listeners and welcome to the first webinar organized by Cremona Automazioni. First, let me introduce myself and present my company to all those customers who still don't know us. I hope less and less. My name is Marco Preti, Cremona Automazioni Sales Manager. I gained my experience in textile field after taking an engineering degree with a specialization in textile automation during over 30 years of technical and commercial activities in this industrial sector. After a first work experience lasting over 13 years at another Italian company in the same field, I'm working in Cremona Automazioni for 17 years. In both companies, I had the opportunity to manage automation projects, following them step by step, from the development phases of the first concept to their final commissioning, passing through sale, construction, and startup. I have therefore always found myself in a position to have a global vision of the problems concerning this type of equipments and installation, acquiring progressive and specific knowledge of the subject in the field and from the field. Feel free, during my speech, to send questions or requests for clarification, live with the chat or using my mail address. It will be my pleasure to read them after this webinar and to give you a feedback in the following hours. Our company is located in northern Italy, not far from Milan, Malpensa Airport and the Swiss ports. Indeed, Cremona Automazioni is an Italian automation integrator, Primon's family owner, which has been present on the European and international market for almost 40 years. Our core business is related with design activities, construction and commissioning of tailor-made equipments for assembling, testing and handling purposes in the following application fields: textile, precisely, faucets and valves, casters and wheels, handles and locks. The company has an internal technical office where we take care of the full customization process, such as the mechanical design, the electrical design and the software design, in both development environments, that is to say PLC and PC areas, and an internal workshop where we take care of the assembling, testing, and final tuning phases before delivery, installation, and startup at customer premises. Our sales organization provides, in most cases, direct contacts with customers and final use of our systems. But for some markets and for some sectors, we are supported by external collaborators, agents like Vamotech in Northern Europe, Sartex in Turkey, or Wellfirm in Far East for textile applications, or single representatives in Germany, USA, and China for assembly applications. With both these commercial approaches, the high level of customization of our equipments and our prerogative of not making standard machinery leads us and our partners to systematically provide our customers with technical consultancy activities. Single machines, as well as turnkey plants, are pre-assembled and tested in Italy and then installed all over the world by internal technicians with specific skills, in charge also to train operator in their correct use before the final release of the supply. Each machine leaving our factory can then be reached from our headquarters at any time via remote assistance for troubleshooting activities or after-sales service support. All these organizational features are recognized and appreciated by the final user of our machines, and they represent a significant additional value for our company, together with experience gained over the years working for the most important players in the textile field. Precisely these applications, that is to say the automatic CREELING systems, are the subject of this webinar, with particular reference to the use inside tufting departments of robotized loading stations to depalletize bobbins and autonomous CREELING vehicles to carry out automatic CREELs exchanges where and when needed. This slide anticipates the contents of the 3D simulations that the colleagues of the technical office have prepared for this event and that I will share with you shortly. In the near future, we will talk about automatic doffing systems, that is to say, mobile robots used in combination with the above-mentioned autonomous vehicles for unloading bobbins from twisting, cabling, extrusion, winding, and spinning machines. In the specific textile field, Primo Automazioni developed challenging applications mainly related with automatic CREELING system, that is to say, with robotized equipment properly designed to fit CREELs by loading automatically bobbins on trolleys or racks, first inside warping and then inside tufting departments. Here you can see our main references in this field. They refer both to customers who have automated warping or beaming departments and customers who have automated tufting halls, equipped to produce carpet or artificial grass, as well as some other applications concerning the automatic unloading of production lines. Some of these customers have multiple robots installed for a total of more than 50 operational robotized stations, different in performance, different in configuration, different in terms of technical approaches, but all united by the fact that they have been customized one by one to meet particular requirements and to reach specific performances, adapting from time to time to different environmental conditions. Project by project, customer by customer, our depalletizing robots equipped with proper handling tools have been linked with CREELs, depending on their configuration, using different transportation systems, overhead manipulators and conveyors or floor shuttles to convey yarn bobbins towards production lines and vice versa to bring back empty cones. For sure, this manufacturing flexibility represented and still represents a further additional value for our company, and it has so far distinguished us. Main focus of this webinar is to bring your attention to the new solution for the automatic loading of CREELs in the tufting process that we are about to introduce on the market, but also to share with you the advantages to be taken in account during the ROI calculation that can be obtained from this kind of automation intended as a smart, flexible, and modular CREELING system. Number one, to increase performance of the tufting machines, reducing to the minimum their production downtime. Number two, to reduce drastically the number of workers involved in the process, up to one single forklifter per shift as a replacement of a group of creelers, and a few people inside creels to use the splicing devices if there are no conditions to introduce also the automatic splicing system. Number three, to automate activities more and more difficult to be manually managed as repetitive and heavy jobs for the operators. Number four, to fit creels with oversized and overloaded bobbins if needed or possible, because handled by robots having big payload without restriction, and thus to reduce the number of creel changes. Number five, to optimize the general efficiency of the whole department, opening the possibility to introduce an MES platform for monitoring and scheduling production flows. Number six, to plan and track shift by shift each creeling section by means of the pre-mount supervision system, properly customized for your special requirement, and MIS compatible manufacturing execution system and linkable. To create the right conditions for implementing the smart factory concept and making it really operational in the context of Industry 4.0 program. Number eight, to introduce in the production flow low maintenance equipments having a long expected life and a friendly operator interface. As you can see from the next slide, the automation we are talking about can be related as a whole with a complete system consisting of several phases where bobbins depalletizing, bobbins loading, and bobbin transporting represent the main steps of the process object of our attention. Starting from some reference applications, I would like to show you step by step what solution we have been using in the past, what improvements later on we introduce in these automation processes, and what innovation we are now going to present. Of course, this presentation is intended to deal only superficially with the application field of this kind of automation, postponing the in-depth analysis to the organization of single meetings at customer premises and visits of production departments interested in being automated. The first creels that we included in our automatic loading systems were V-shaped creels used to unwind raw cotton yarn, single color, with the purpose to feed working machines for producing beams. Under this scenario, bobbins are depalletized outside creels and temporarily parked on a buffer, then brought inside the line and transferred to the racks, pushed out onto supporting beams. As you can see from the following installation layout, those applications that have led the way to the others were consisting of multiple robotized loading stations, one per each of the three existing working lines, due to the large volumes of bobbins to be handled, linked with those creels, as you will see in the upcoming video, by means of manipulators traveling automatically on overhead sliding rail guides inside the internal service corridors. For the first time in textile field, I'm talking about 20 years ago, we were guiding anthropomorphic robot by means of vision system, black and white cameras, for depalletizing purposes. In that case, robots have been used for loading bobbins and removing cardboard separators. Empty cones were removed inside creels and wooden pallets were overlapped by means of pallet stacker. And those robots were equipped with double handling tools consisting of self-centering chucks and external suction cups. This solution is flexible and very performing because each production creel is fed by its own robotized loading station, but it is convenient, let me say necessary, only when volumes of bobbins to be handled are extremely large, 600, 700 bobbins per hour per machine. The following step of development of this kind of automation using technology available 15 years ago was again related with the warping department, but unlike the previous one, for this project, the robotized station, consisting of one robot mobile by means of wheels platform along a straight path, but only with intervention of the operator, has been shared with multiple production lines, aligned with each other. Under this scenario, bobbins are still depalletized outside creels and temporarily parked on a buffer, then brought inside the line and transferred to the racks, pushed out onto rotating panels. As you can see, having kept the original configuration of the creels on two levels, first and second floor, the same platform has been designed and sized for transporting not only the robot, but also two service vehicles. They are also capable of traveling in one direction only, back and forth, used for transporting and distributing yarn packages inside corridors. The first one running at the floor level, and the second one running at the race level. This working configuration represents a good solution only when volumes of bobbins to be handled are not too high, 200 bobbins per hour per machine, and the configuration of the creels, not too many inside the same department, allows to have space next to them and time available to load them. In that case, the robot has been used for loading bobbins and removing cardboard separators by means of a multiple handling tool consisting of 3 self-centering chucks and internal suction cups. And the service shuttle has been used to transport bobbins inside the creels. Empty combs and wooden pallets are manually removed by the operator. This solution requires a large service corridor just in front of the creel, and it certainly does not stand out for performance. Referring to the two applications just described, after having examined the main characteristics of the tufting holes, the further development step was quite logical, and it was corresponding with the idea to feed multiple creels inside the department consisting of several tufting machines, no matter how they are laid out on the ground, with groups of stationary robots properly sized on the basis of the consumption of the entire department. In front of tufting machines having lower performance than the warping machines subject of our previous applications, we worked to find proper solution to connect these robots to the numerous creels present in the tufting hole. Therefore, the basic concept of having a centralized station, even if consisting of several robots, has been maintained, but in such a case, the yarn transportation and the connection with tufting machines has been realized by means of overhead conveyors, circuits with caterpillars outside creels, and powered rails inside creels, used for moving trains with bars properly designed for supporting bobbins. Under this scenario, bobbins are still prepared outside the creels and directly loaded onto the racks, intended as train consisting of pin bars, which are movable. Important advantage of this solution was the fact that it no longer needed the use of creels with double working positions, compared to the real number of bobbins requested by the machine gauge, because the management of the tufting department has become possible thanks to the presence of buffer creels positioned between the robots and the production creels, now consisting only of the floor level and no more using platform as second floors. Furthermore, when space is there, such a solution allows to perform very fast creel changes, allowing the trains containing empty tubes to exit from one side of the creel, while the corresponding train containing full bobbins can enter from the opposite side. Last but not least, under this working configuration, both left and right internal corridors inside each creel lane can be used to make running automatic splicer devices. Of course, the opportunity to fully automate also the splicing process inside creels at the floor level is feasible only considering the possibility to prepare tails outside creels before feeding them. This operation consists of searching automatically yarn ends, single-noted around bobbins, by means of proper devices designed for the purpose, and placing them in fixed position on top of each supporting pin by means of additional robots necessary to balance the loss of performance due to the additional operations carried out. Under these working conditions, the first robot in charge for the pelletizing and guided by a vision system is equipped with a tool consisting of self-centering chucks for the pelletizing bobbins, one for conicals and one for cylindricals, and external suction cups for removing cardboard separators. While the second robot, in charge for loading bobbins on trains and positioning yarn tails on pins, is equipped with a tool consisting of grippers for handling full bobbins and empty combs from outside, and fingers for gripping yarn ends. As a whole, this solution is very flexible and very performing, because the overhead conveyors allow to create circuits adaptable to any type of layout, and the centralized loading station allows to be sized accordingly with any production requirement. 15,000, 20,000 bobbins per day per department. Starting from this kind of creeling systems, our company has started to develop in-house supervision software properly customized for managing trains in transit along the overhead circuits, with the purpose to convey and direct them where and when needed by means of the pneumatic switches present along paths, like a rail station. A few years later, in presence of tufting departments where spaces between creels and machines were not wide and where quantities of bobbins to be handled were not so big, the same concept previously described was taken as reference with the purpose to feed tufting machines, but with the difference to use floor shuttles, a fleet of smart vehicles, batteries powered and traveling in two directions following underground tracks, in place of the overhead conveyors for transporting yarn and for connecting the centralized loading station, able to manage multiple colors, with the machines, no matter how they are laid out on the ground. Under this scenario, bobbins are still prepared outside the creels and directly loaded onto the racks, intended as double-faced panels with supporting pins, which are movable. Panels are hanged up inside creels to form a train. This means that with this solution, taking as a starting point to develop the new application shortly described, each production creel lane must be split in sections, 7 in this project taking as an example, and each section is transported by one of the vehicles of the fleet. The lack of space near the machines involves the fact that both the removal of panels containing empty combs and the insertion of panels containing full bobbins take place on the same side of the creel, opposite to the tufting machine. outside creels, the same vehicles, equipped with two groups of powered wheels perpendicular to each other, can change their direction, switching such groups. Due to these working conditions, the creel changes, in this case, take longer than the previous example, but the possibility to reach multiple creels, however, make the solution flexible and interesting. Also, in this case, the creels with double working position are no longer needed because the management of the wool tufting department become possible thanks to the presence of buffer creels positioned between the robots and the production creel. The twin robots, as always guided by vision systems, working simultaneously on both sides of the panels, were used for depalletizing and loading bobbins and for removing cardboard separators and wooden pallets. Each of them was equipped with a tool consisting of a self-centering chuck for handling bobbins and suction cups for handling interlayers, and it was able, when needed, to engage automatically from an external parking station, an additional gripper used for handling and overlapping wooden pallets. Empty cones were automatically removed from the panel in transit before approaching the robotized station by means of Cartesian manipulators, and then collected inside containers by means of underground belts. As a rule, this solution is quite flexible and quite performing, because the floor shuttles allow to have paths adaptable to any type of layout, and the centralized loading station allows to be sized accordingly with any production requirement. 5,000, 10,000 bobbin per day per department. Before moving on to introduce and describe the new creeling solution that Primona Automazione is about to put on the market, I would like to spend a few more words on the system that use overhead conveyors to transfer bobbins into the creel, with specific reference to the possibility of exploiting the operating features of these systems also to manage tufting departments that produce artificial grass. Indeed, even if these departments have the need to feed the production lines with yarns having different consumptions, and therefore to make partial creel changes during processing, the train handling system still allows to meet this requirement by loading different yard types on different trains and configuring the creels gauge by gauge in such a way as to have an even number of planes, as shown on this layout. Under this scenario, bobbins are still prepared outside the creels and directly loaded onto the racks, intended as train consisting of pin bars, which are movable. The system, configured to allow the production of artificial grass, therefore differ from those configured to produce carpet for the fact that the supervision software provides for a dynamic and flexible management of the trains in preparation next to the robot and in transit inside the transport circuit in order to make possible partial replacement of yarn during the production cycle of each tufting machine present in the department. As regards the specific configuration of the centralized robotic station, in the case taking as an example and relating to a system sized to handle 15,000 bobbins per day, a total of 4 robots was used, working simultaneously in pairs on both sides of the train in transit. 2 of them used to depalletize, and the other 2 used both to unload empty cones, 2 at a time, and to load full bobbins, 2 at a time. Empty cones were collected in plastic containers by means of floor and overhead belts properly laid out on the ground to reach the warehouse. Of course, also this solution is very flexible and very performing because the overhead conveyors allow to create circuits adaptable to any type of layout, and the centralized loading station allows to be sized accordingly with any production requirement. Even if both the existing solutions today at disposal of our customers for feeding automatically tufting machines, stationary robots and overhead conveyors, or stationary robots and floor shuttles continue to meet the expected operational requirement associated with this kind of equipments, ensuring all the advantages previously described, nevertheless, in the past few months, Primona Automazioni, always searching for innovation, has carried out new development activities regarding these CREELING applications, with the only target of making more and more cost-effective the investment related with the automation of the creel loading process inside tufting department by means of autonomous vehicles for transporting bobbins, always in combination with stationary robotized station for handling them and single-level creels consisting of movable trolleys. Indeed, both solutions used up to now, compared with the new one, have always required and still require the widespread presence of fixed infrastructures due to a large use of columns and supporting beams inside departments in which they are introduced in case of overhead conveyors, or important floor preparations due to the need to carry out the ground positioning of the guiding track in case of floor shuttles, involving prolonged and significant building and plant engineering activities. Furthermore, the existing solutions, while always allowing connection with all the creels which are present in the tufting department, adapting to the different layouts, and for this reason defined as flexible, in practice, once installed, are quite difficult to be reconfigured, and even if they are expandable. All these limitations do not exist anymore with the new proposed solution, because the commissioning of these autonomous vehicles, only consisting of the path mappings, is quick, it's simple, and it does not need preparation except the requirement of having a flat concrete floor in good conditions. Hence, our effort in going to offer our customer from now on the possibility to achieve also these new important goals as further benefits to add to the others. Number 9, to eliminate completely the aforementioned construction site activities, minimizing installation times and reducing commissioning costs. Number 10, to make these systems easy reconfigurable, completely releasing them from the ground arrangement of the tufting machines and relative production creels, even doing without building buffer creels. Number 11, to need, last but not least, glider creels, that is to say, creels no longer made to support height loads. The solution that we have found to reach this target and to achieve this goal, maintaining the original concept of having a centralized loading station properly sized to guarantee the expected performance, corresponds to the simple but smart idea of using autonomous and omnidirectional flat vehicles, known as turtles, that can slip under the trolleys and carry them inside creels by lifting the panels on their backs. As shown in the following simulation, developed as possible basic application related with the automatic management of single tufting machine, the vehicle that we want to use, much slim and more performing than those already used in the past, is able to feed by itself fully automatically and without any fixed equipment the production line, making it possible to transfer not only the panels containing bobbins from the robotic loading station to the temporary parking area and vice versa, but also to carry out their following insertion into the production creels, after removing the panels containing empty combs, passing to the buffer creel. Under these working conditions, the challenge is to balance the use of the single vehicle between the robotized cell and the tufting area. Approximately, in order to give you an idea of the vehicle's performance, in the time in which the robot unloads and loads one trolley, picking 60 bobbins up from a pallet and handling 60 combs, the shuttle is able to remove from the production creel 7 empty trolleys and replace them with 7 full trolleys, taking them out from the buffer creel. Of course, the total number of panels associated with each tufting machine changes according to its gauge. In this case, the production creel has been sized to contain 4 lanes of panels of 7 units each, thus corresponding to a total of 28 trolleys, equal to 1,680 bobbins. The space on the ground, the virtual buffer creel, reserved to the temporary storage of the panels in work in progress, has been sized instead to park on the floor a total of 56 panels, 28 containing bobbins previously loaded by the robot, and 28 containing the empty combs removed from the machine to make room for the others, distributed over 8 lanes. Indeed, in order to optimize the creeling and the splicing processes, the best possible recommended working sequence to be accomplished by the vehicle corresponds with the replacement of one group of trolleys, let me say 1 lane at a time. As you can see, the vehicle is used first to remove 7 trolleys containing empty combs from the production creel, here located on the right side of the screen, and to transfer them inside one corridor of the buffer creel, here located on the left side of the screen. Then the same vehicle is used to remove 7 trolleys containing full bobbins from the adjacent corridor of the buffer creel and to introduce them inside the lane just emptied. The same sequence just described is repeated 3 more times, as many as there are lanes, with the purpose to clear the buffer and to complete the creel replacement. This solution allows to perform the unloading and the loading process of the tufting machine in a completely automatic way, removing the panels containing empty combs after the yarn has been consumed and replacing them with as many panels containing full bobbins by means of autonomous guided vehicles, which are configured and sized in such a way as to pick up and drop off 1 trolley at a time by slipping under the frame, raising the platform to lift it, and then transport each panel under safety condition from side to side of the tufted department, with the target of replacing those containing empty combs with those containing bobbins previously prepared by the robot and temporarily parked inside the buffer without any intervention by the operator, but above all, without the need for any fixed infrastructure and following paths easy reconfigurable. The same vehicle, movable longitudinally along the creel front and transversally along the internal corridors, it is therefore possible to manage the entire creel change process, the duration of which, obviously, can change depending on the number of panels to be managed and the distances to be covered inside the tufting hole. Of course, the same working section can be completed in a shorter time if the number of vehicles used increases. Indeed, as shown in the next simulation, a fleet of 7 vehicles, that is to say 1 vehicle per each trolley that make up a lane, can easily and quickly exchange 1 creel, removing 7 trolleys containing empty cones and introducing 7 trolleys containing full bobbins, with the purpose to create, in the shortest possible time, the conditions for entering the same creel to splice the threads, by hand or automatically, if there are the conditions. It is clear that the growth of vehicles is a consequence of the growth of the overall plant performance, and it must also be associated with the use of an increasing number of robots in order to catch up the production. In both cases, the management of the single vehicle or the fleet is entrusted by an updated version of our supervision system, in charge to control the traffic of the vehicles and to put in the right sequences their working missions, accordingly with the CREELING requirements. This 3D simulation has been referred to an ideal tufting department consisting of 5 tufting machines, here interfaced with production creels having the same size. Of course, inside the real tufting department, machines have different gauges, and so creels might have different dimensions because sized to fit different number of bobbins in working position. Compared with the previous layout, this loading station has been doubled since it is now consisting of 2 robots working simultaneously and managed by a specific service vehicle dedicated to the exchange of panels in work in progress. That is to say, the insertion of trolleys containing empty cones and the removal of trolleys containing full bobbins, while the fleet of vehicles are traveling inside the tufting hole, patrolling the production creels. The buffer creel is the same than before. Under these working conditions, the duration of each creel change has been significantly reduced. Project by project, application by application, we take care to analyze the environmental conditions and to calculate, together with the final user of our equipment, what is the right number of stationary robots to be placed on the floor and what is the right number of movable vehicles to be introduced in the tufting department in order to reach the requested performance. We like to highlight the fact that both these equipments, robotized stations and CREELING vehicles, are modular and they can be installed step by step as further confirmation of the high flexibility of the whole system and the quick commissioning of these vehicles. To integrate the new CREELING systems just described, taking up the development of the already existing splicing devices used in production for the first time 10 years ago in a tufting department, I would like to conclude this webinar by bringing your attention to the will of Primona Automazioni to follow up also this new application. In particular, in order to reach the target of making also this equipment more usable because more cost-effective, up to now characterized by the fact that it can only be used in the face of important preparatory works in the creel corridors in which it was operating, the recently resumed study plans to simplify the original device, originally equipped with as many fixed splicing heads as there were creel levels, by equipping it with only 2 heads vertically movable along an axis whose movement inside corridors will be entrusted to the same vehicle used to transport bobbins, properly integrated with it. Referring to the final working configuration, by means of a couple of autonomous splicing vehicles customized for this purpose, it will be possible to travel simultaneously both corridors, right and left, inside the production creels, properly preparing the treads ends on the panels with the operating methods above described, without the need to install any longitudinal fixed guide as done previously, and performing combined splicing cycles thanks to interchangeable junction devices accordingly to the specific application, carpet or grass. To allow the use of both types of vehicles, those used to transport panels and those that will be instead used to move such mobile splicing devices, the new creels, single level, still necessary as they replace the conventional ones, double deck, must be properly configured to allow both vehicles to travel along the internal corridors, crossing them longitudinally from one side to the other, according to this schematic sectional view. The space available between one creel lane and the other will still allow the operator to manually intervene in fixing any failed joints by the system where necessary, and indicated by the system itself that it is already happening. I really hope this preparation was clear enough and succeeded in arousing your interest. I confirm my availability to collect possible questions and to provide you in the next few hours by email with answers or further information regarding the applications today described, referring all the relevant insights to target meetings with anyone interested in taking up the topic in his own production environment. Meanwhile, I would like to thank you for your time and your attention, and I give you appointment at the next webinar organized by Primona Automazioni.